All right, so we've got a little uptick in solar activity here, not one that's accompanied by an increase in the sunspot number or the radio flux, but there is a coronal mass ejection, and it may have an earthly directed component. We suspect that it does. Also, an M-class flare erupted around 2250 Universal Time on the western limb. So if the data looks a little differently today, it's because it is the SDO browse data as opposed to the HelioViewer movies that we usually show. So first of all, there was a CME off here on the eastern limb. So let's let that play through. That is yesterday, August 26th, and today, August 27th to date. So there are still massive filaments hanging out as well. We'll let that play through one more time. So a little uptick here. A minor CME impact is possible on the 30th. So sometime around midday, we're expecting a possible CME impact. Here is our house favorite wavelength, 171 angstroms for the same time period. We'll show you all the details of that here. After that plays through one more time. Again, this is the SDO browse data feature. That is 171 angstroms ionized iron. So here's the sunspot situation over the past same period of time. We just sped that up a little bit for sake of compactness, and really not a lot of changes to cover there. So we've got setting sunspots there in the west. That is where that M-class flare came from. It came from behind the limb over here. But the likelihood of large flares is now in the eastern limb. So we're expecting the possibility of large flares somewhere down around this area, below the equator around the east. So there are some likely sunspots rising over there. Here's colorized magnetogram for the 26th and the 27th of August to date. So again, not a lot of changes happening there. And we did stream. Here it is. Again, the most significant event that happened here was this M-class flare, which we will cover here momentarily. And there was a huge prominence. There still is a huge prominence hanging out there around the western limb. And you can see some activity rising up here around the eastern limb as well. So we'll show more of that here momentarily as well. First, let's take a look at planet Earth. And we've seen a seismic downtick, but as far as volcanoes go, it looks like a volcanic uptick. So here are the volcanoes that are erupting. Semeru on East Java, Indonesia is producing a 15,000-foot ash plume as it explodes. It's a flight level 150. Dacono, 7,000-foot ash plume over Halmahera. Central Mexico featuring Popocatépetl now exploding. Flight level 230. It's a 23,000-foot ash plume there over the central Mexican volcano. Santiaguito, no recent volcanic ash observed in Guatemala from it. However, Fuego exploding to the tune of 15,000 feet for its ash plume. It's a flight level 150. Down to Colombia, Nevado del Ruiz exploding. Flight level 240. Ecuador, featuring Sangay and Revenador. 23,000-foot ash plume over Sangay, 13,000-foot ash plume over Revenador, and flight level 220 over Sabancaya in Peru as it explodes. And also Ubinas here remains on the list with a similarly sized ash plume in terms of altitude. Flight level 220, it's a 22,000-foot ash plume. And here's the seismic downtick. So we've had 0 5+ magnitude quakes over the past 24 hours, and we're in a 7 magnitude earthquake drought. So this could be the calm before the seismic storm. And again, that's the 90-day bar graph. Here's the past 24 hours. Again, 0 quakes of a 5 or greater magnitude. So if there's anything we're missing on the list here, hit us up in the comments section and let us know about it. We usually cite quakes of a 5 or greater magnitude, and we ain't got none. 0 quakes of a 5 or greater magnitude for the past 24 hours. So that's what's going on Earth. And let's get back to space with some more fantastic imagery from SDO. So here is yesterday plus today. In some wavelengths we don't usually show. This is a three-way composite. 2 species of ionized iron there and 1 of ionized helium. So in this one, keep in mind, folks, the 211 angstroms is shown in green and 171 angstroms is shown in blue. Those are usually purple and gold, respectively. 304 angstroms in this one, ionized helium, is still red. So this one shows great depth in the solar atmosphere and also the extended corona. That's especially the 211 angstroms wavelength there. You can see all that green around. Keep in mind this is all ultraviolet light, so it is not visible to the naked eye anyway. These are artificially colored, very specific bands of the extreme ultraviolet spectrum. And since we're using the SDO Browse Data feature, here's one that we can't even get on the helioviewer.org site in the first place. It's colorized magnetogram in addition to 171 angstroms. So that's going to show you the polarity of active regions as well as the lower quiet corona depicted by 171 angstroms. Moving right along to the 10.7 centimeter radio flux, which is now still only at 139 solar flux units. So a great example of how you can see an uptick in solar activity without an increase in the sunspot number or the radio flux. We take a holistic perspective when it comes to reporting on what the sun is up to, as there are a lot of features besides the sunspot number and the radio flux, but there they are depicted in a 1-year chart. The red line is the sunspot number, and the black line is the radio flux. Now, NOAA's not forecasting any CME impacts or anything like that. There is NOAA's forecast for the next 3 days. We did get into geomagnetic unrest briefly. It was a very mild, really a magnetic field shift, which we'll cover here in a moment. That happened last night. Again, NOAA not forecasting any geomagnetic storms or anything like that in the next 3 days. As far as NASA's concerned, no new forecasts from NASA either here. So this one might be updated at the moment. No indication of really anything interesting going on in terms of anything headed toward Earth. We'll keep you posted. Perhaps on tomorrow's Daily Space Weather video, we'll see something else here on this Enlil spiral. At the moment, no CMEs forecasted by NASA or NOAA. Moving on to Earth's magnetic moment from space for the past 4 hours. Here's our geospace magnetosphere movie, and it is a rather high-pressure plasma environment around the planet. However, the inputs from the solar wind are pretty mild. So that's magnetohydrodynamic pressure for the past 4 hours. Pretty homogeneous here at the moment. Here's Earth's magnetic moment from the ground, and there may have been some significant aurorae sparked up in the past few hours. It certainly looks like there were. This depicts magnetic flux density at the ground level, Earth's magnetic moment from the ground. Changes to Earth's B field, geospace delta B, in nanotesla. Those are the most likely places to see the aurora, telluric currents, pipeline, railway, and power grid induction. So the KP index did get up to 3.67 here. It's mild geomagnetic unrest, and it was really just caused by a shift in the magnetic fields, the vertical component of which can induce more electrical current to flow into the Earth system. So that is the planetary K index, currently only at 2.67. And here's the real-time solar wind to show this is when this happened. Right around this period of time here, we saw a BT-BZ of 7 nanotesla for the BT and BZ of -7 there. So that was sort of around that period of time. A great example how just a shift in the magnetic field's vertical component, which is that red line there, the BZ, can induce geomagnetic storm conditions. Besides that, it was calm. Just a nominal solar wind there and not a high density spike or anything like that. Just a mild little shift happening there. Current conditions are 4 protons per cubic centimeter for the solar wind density, and solar wind velocity here 378 kilometers per second. Pretty unremarkable indeed. There are our GOES magnetometers measuring the magnetic fields from their geosynchronous near equatorial orbits. They're sort of in the outer reaches of the outer Van Allen belt there. and some spikes happening there accompanying that shift in the magnetic field. Keep in mind this is measured from within inside the Earth's magnetosphere. The solar wind is measured outside Earth's magnetosphere about 1 million miles away at Lagrangian point 1 by the ACE and Discover. Next, looking at the top view ecliptic plane field plot. And Earth is in a North Pole current sheet here at the moment. I would expect this to continue. No changes expected there. North Pole current sheet here depicted in green. South Pole current sheet depicted in red. And let's take a look at the line of sight field plot next. Before we get to coronal holes, here the solar B field is depicted in blue. And let's look at coronal holes. Here's our coronal hole line of sight plot. And it looks like we do have some South Pole coronal holes here rotating in. So a little bit of South Pole coronal hole showing up there in the northeast. And some setting in the northwest. Besides that, North Pole-oriented coronal holes. Let's look at those from SDO. There's SDO 211 angstroms. Again, that is August 26th and August 27th to date. And next, we'll look at sunspots. So here's a sunspot situation. Again, no changes happening here. We do have a high likelihood of large solar flares on the eastern limb. So that is especially right around this area here. We've got some plasma filamentary behavior going on over there and so forth. Let's take a look at sunspots here up close. And we've zoomed way in on the equator here to show you all those groups. A little bit of growth actually on the leading edge of this large sunspot group up here. That does raise the likelihood of solar flares a little bit, right on the Earth-facing portion of the solar disk. So there is a significant possibility here of large solar flares. In fact, check out the flare monitor. It's showing the likelihood of C-class flares 97%, M-class flares 51%, and X-class flares 12%. Next, energetic particles and solar flares. That M-class flare that happened around 2250 Universal Time last night did not generate any SEPs, solar energetic particle events. The proton flux remains flatlined. And there is the X-ray flux. So again, around 2250 was the peak flux of that M1.1 flare. Certainly the largest solar flare event in the past 24 hours, and it was quite long duration. Let's take a look at it in detail. So here is the 131 angstroms wavelength, which is one of the wavelengths specifically formulated to view solar flares, and you'll see that popping off on the western limb there. Let's briefly zoom out and speed this thing up. To show you time and date stamps. There we go. And we'll also show 94 angstroms. And let me actually rock this back here. I think this is the best wavelength to show this. All right, M-class event here happening on the eastern limb. So almost a simultaneous event there. Largely happening out of view of Earth. Let's actually go back here. And there is that M-class flare on the eastern limb. Right there. Right around 2250 Universal Time. So there you go, a great view in 94 angstroms. Several events happening there, including one right in the center of the solar disk, which may indeed involve some ejecta headed directly toward Earth. Although we do suspect most of it is going to miss to the east. All right, so let's step back from the sun here for a minute and see what's going on overhead Lehigh Valley, Pennsylvania. We're going to talk about Deneb here for a moment. We got the sun just peeking over the horizon here, just behind Regulus. Also Jupiter up there high in the sky. Saturn has already set. And before we talk about Deneb, let's do a solar system forecast. This is where things are today. We'll advance this 1 week for your solar system forecasting pleasure as we approach the August blue moon occurring on the 31st. There's where things will be on September 3rd. Next, the astronomy picture of the day, the Great Comet of 2007 and 3 galaxies. Which galaxies, you ask? The Milky Way, the Small Magellanic Cloud, and the Large Magellanic Cloud. That's the apod.nasa.gov astronomy photo of the day by Miloslav Druckmüller. apod.nasa.gov if you want to check it out yourself. And let's talk about the most bright intrinsic object visible from our solar system. It's a binary system. It's a what you call a high mass X-ray binary. And here are the X-ray outputs from it. These are the hard X-rays from Cygnus X-3, the little friend of a Wolf-Rayet star, which is believed to be something like a black hole or a quark star or a neutron star orbiting a massive star at incredibly high relativistic speeds. One of those jets is directly oriented toward Earth, and it is one of the brightest X-ray sources in the sky, located in the constellation Cygnus. It is part of the star Deneb. So again, that is the brightest intrinsic object visible from our solar system, and it's also the only known cosmic ray point source. If you want to go follow its hard X-ray emissions yourself, check it out at the Neil Gorell's Swift Bat X-ray Observatory, the Burst Alert Telescope. Just type in SIG space X-3 and you'll get to entry number 952. Those are the hard X-ray outputs from it. And if you want to read more about the only known cosmic ray point source in the world, by the way, there's an image of it. This is the little friend right here. And what you're looking at there is this. First of all, this is X-ray, and then this is radio. And what this is a jet that's oriented away from Earth, and this is a jet that's oriented directly toward Earth. So that is there's a huge filament in between Cygnus X-3 and planet Earth. This is this massive Wolf-Rayet star, and the periodicity of this system is only 4.8 hours. So that star is so huge that if it were in our system, it would be about the size of Jupiter's orbit. It's like about 170 times the size of the sun. And it's just 1,700 times the size of the sun, I should say. So it's a pretty weird place. Cygnus X-3, you're part of its stellar sphere, as this jet is oriented directly toward you. It's the tail of the swan. The ancients seem to know something about it, and humans didn't really know about it until in the early 1980s during the monitoring of a proton decay detector under both Minnesota, under a half mile of granite, as well as underneath France's Mont Blanc. They detected the presence of highly unusual cosmic rays. And it took a while for them to figure out what it was. It turned out that it was Cygnus X-3, which has a relativistic jet that is blasting mainly hydrogen nuclei through space at extremely high speeds. So here's another image of Cygnus X-3 right there by the Chandra X-ray telescope. If you want to read more about it, check it out at smashomash.com/forum. We have a whole entry in our cosmology forum about Cygnus X-3. probably the most important single object in the entire galaxy with respect to our location in it, as this does have a relativistic jet that certainly affects things on Earth, as again it is providing cosmic ray flux, the only surely known cosmic ray point source. And why don't we know cosmic ray point sources? Well, it's because cosmic rays take a crazy path through space. Most of them don't take a straight path like Cygnus X-3's cosmic ray jet. Cygnus X-3's cosmic ray jet has this very specific periodicity of 4.83 hours. And you can actually see that depicted in the X-ray imagery as well. So you see this 4.8 hour periodicity. It is an eclipsing binary. It is a crazy place. Cygnus X-3, folks. The weirdest and probably most important object with respect to planet Earth and our solar system in the entire galaxy. Next, we'll move on to look at coronal mass ejections. And again, late night, there was one generated that may have an earthly directed component. These are 90 frames from yesterday, and this will be a little more obvious in today's frame, so let's advance to today's frames to date. Here are an additional 36 frames from today, and you'll see the tail end of a CME coming out of the eastern limb there. I do suspect that has an earthly directed component, so let's take some more detailed imagery here. So first we'll look at stereo A, and we like to put this up just to show people where stereo A is located. It's slowly getting to the west of the Earth. This imagery also shows the solar orbiter, Bepi Colombo, the Parker Solar Probe, stereo B in blue. Stereo A is that red dot there, and here is stereo A's difference imagery on the right and the raw coronagraph imagery on the left. So this one may have an earthly directed component, folks. If so, we expect that to arrive sometime after midday on August 30th. It may miss entirely to the east. We'll have to see what others say about this. And we may be able to tie together some more data here, but unfortunately the lack of HelioViewer movies is not helping. So that could be an earthly, not really an earthly directed CME, but one that has earthly directed components. So there late in the day on the 26th, you can see that CME out of the west, and then this one out of the east later in the day, early this morning. Maybe behind the solar limb. So we may have to make another video about this later today when that data does become available on HelioViewer so we can tie everything together. Here is the view from Soho Lasco C2 and C3. Now these are located at Lagrange 1, right in between the Earth and Sun. So let's bring those back a couple hours here and let those play through. So we don't see a halo there. Could be behind the eastern limb, as there could be multiple events there kicking off at the same time. So let's bring that back one more time and play that through again. There you can see that smaller event off the western limb, and then this much larger event off of the eastern limb, associated with that M-class flare event. And again, the likelihood of additional flares on that eastern limb is very high. So here's another composite we don't always show on the channel. It's now it's 335 plus 193 plus 94 angstroms. So 3 species of ionized iron there. 335 is in green. Normally that's blue. 193 is in blue. That's normally like a pinkish color. And 94 angstroms, which is normally green, is depicted here in red. So there you go. And let me just bring this back. So late in the day yesterday, the heck? That's actually not showing anything from today. That's check it out. That ends at 1949. All right, let's try this. All right, so before we get to filaments, we'll look at 193 angstroms because this is going to show us data from today. That's always helpful. All right, so here's the time of this flare event. Again, it was around 2250 universal time. we'll just let that play through. Definitely some plasma reorientation happening here in the center of the solar disk, so that is something to pay attention to. I suspect that was a coronal mass ejection there. So very hard to tell based on the data that we have and the lack thereof. So let's look at filaments next. So here's our hydrogen alpha telescope at Lurmonth, Australia. And check it out. So this filament right here, it looks like it's still intact there. So I don't suspect that that has ejected, as it is still there. It looks like it just reoriented itself or something like that. And let's also look at the grayscale to show prominences, as we have significant prominences all around the solar disk. So check that out. Significant prominences both in the west and in the east. Also one hanging out up here at the northern polar region and the southern polar region. Two at the southern polar region, actually. So lots of filaments there, especially on the eastern portion of the solar disk there. We do have a significant uptick in the likelihood of coronal mass ejections headed Earth's way. By the way, we've been naming them after living people. This one up here in the northeast we've named Mike Bordage's filament. This one down here in the one that may have ejected but it didn't, that's called the Rene Gable filament. And then this one up here is called the Ben Schouten filament. If you want to name filaments after living people, join us over on Twitter. Just follow the hashtag #NameThatFilament and you can name filaments after your friends, foes, neutrals, or even yourself. So here's the GOES 16 SUVI for the past few hours, and we do have this crown prominence hanging out up here at the North Polar region. That is the past approximately 2.5 hours, and you can see quite a bit of filamentary motion happening all around the solar disk. So you can expect CMEs to start happening at any moment here. And by the way, fun fact, we're still like a year out from solar maximum. So if you think it's getting exciting now, just wait. It's going to get a lot more exciting. Solar cycle 25 may turn out to be a stronger solar cycle than solar cycle 23. There's no doubt that it's a stronger cycle than solar cycle 24. It's not even close. But if it's a stronger cycle than solar cycle 23, that makes it a pretty strong cycle. So one of the strongest cycles of the modern age we could be witnessing ramping up right now. Anyway, let's move into our bonus feature segment, starting out with satellite charging hazards. We only have some minor surface charging hazards here over the eastern Pacific and Mexico. No big deal there, not likely to cause any major communications breakdowns. GOES electron flux here, kind of low at the moment. That's the past 3 days as measured using radiography from the geosynchronous orbits of the GOES 16 and GOES 18. Here is the greater than 2 megaelectron volt electron fluence. It's the same measurement. This is just the 1 year graph in a low to moderate range here. Here's the NOAA forecast. And NOAA forecasted it a little bit lower than it actually was. So, yeah, expecting an uptick here in the coming days. I would tend to agree with that forecast. The green boxes are the forecast. The yellow diamonds are the observation. Again, that is measured at the F layer of the ionosphere, up there at about 300 kilometers of altitude. Let's take a look at the vibrational frequency of that layer. The bridge between Earth and space. Now, we do have significant low-frequency anomalies, as is something that is typically accompanied with geomagnetic storms. That little shift in the magnetic field caused some shifts in the ionosphere. So let's show the anomalygram next. And you'll see a lot of red. That's low-frequency anomalies. That is depicting anomaly in megahertz from the 30-day median. So lots of red on there, lots of low-frequency anomalies showing up there. Again, typical of geomagnetic unrest conditions. It was very minor. You can expect this to be completely subsided by the end of the day today. That little shift in the magnetic field's not going to cause any kind of long-lasting effects on the ionosphere. And here's the latest image. That's 11 o'clock universal time for the ionogram and 11 o'clock universal time for the anomalygram. At the moment, some north polar low-frequency anomalies happening. The ionosphere a little bit puffy up there. Next, the total electron content forecast, depicting free electrons up to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're not familiar with those distances. Here is the total electron content forecast. That'll show you the most likely places to see GPS errors. And let's show North America's total electron content anomaly. That is anomaly from the 10-day average, and we are seeing high electron count anomalies here over northern South America. Also over Mexico, even parts of the central U.S., even part of the Gulf states there. So let me just bring that back. So some high electron count anomalies. Some in the central U.S. there. Some around places like Texas and New Mexico. Also Central America. We'll play it through one more time, and then we'll show high-res imagery of the sun, and then we'll move on to meteorology. Hopefully without making the video too lengthy. So that's total electron content anomaly from 10-day average. Here is the latest SDO intensitygram and the latest SDO magnetogram. Again, we are expecting to see a sunspot rise somewhere around this area. That is also the most likely place for large solar flares at the moment, followed by this sunspot. Also, this sunspot does have some significant magnetic shear. And there still is a fleeting possibility of flares from that northwestern limb. So here's a brief look at these two large sunspots. It is beta gamma class. It is beta gamma delta class, but just barely. It has grown some additional umbrae on its leading portion. Here's that other sunspot. I don't memorize the numbers. That one is also... That one's beta gamma delta class just barely as well. So again, the most likely place, in my opinion, to see a large flare is actually over here. We've got quite a lot of plasma motions happening over there and a likely large sunspot rising. Second most likely place for a flare is here, and the third is probably this sunspot group here. So that is the space weather section of the video. Now it's time to talk about meteorology. So the first thing we're going to do is some wave chasing. I'm a wave chaser. What about you? Here are the largest waves in the world, 40-footers off the coast of Japan. So surf's up on Japan, most likely there. That is depicting wind in the animation portion and waves in the color gradation portion. Southern Ocean featuring some big waves also, but not quite as big as those ones off the coast of Japan. These tropical systems in the Atlantic and the Pacific not really stacking up to any big waves. So let's take a look at weather patterns here. There is the surface wind environment for the eastern world. Here is a jet stream scenario for the east. Jet stream blowing backwards over the northern Indian Ocean. Jet stream scenario for the central world. Surface winds of the central world. Surface winds of the west and the jet streams of the west. Now a little bit more coherent over the U.S. and an anticyclone here now over Arizona. So let's take a look at these lows, one in the Gulf and one in the western Atlantic. So this is the GFS forecast for pressure. We're going to move this ahead 3 days. So first of all, this low is going to strike land here. That's going to bring some significant rains. And this one is going to be turning to the northeast. So not likely to make landfall there. And it's going to start encountering some wind shear by about Wednesday. So the jet stream is going to make some effort to push this off even more and probably break down its pressure as well. We'll keep you posted to what's going on there. That's the GFS forecast. Here's the Euro forecast. The Euro forecast has it a lot closer to Bermuda there. So big difference in the GFS and Euro forecast there over the next 3 days. There's the Euro forecast, and there is the GFS forecast. Moving right along to show clouds and fog. Shortwave radiation over the Americas. And this system's slightly less organized than it was yesterday. We showed an eye wall form, and it has since collapsed. Next, your smoke forecast, and there's some heavy smoke there in northern Canada. Also, the Pacific Northwest seeing some extreme smoke, especially in Oregon. That's your smoke forecast from firesmoke.ca. Here's your weather.gov map. Expecting some flooding there around coastal North Carolina. Mostly heat advisories showing up there. Also Alaska seeing some rather significant weather. And let's do a forecast. There's your GFS 72-hour pressure and precipitation forecast. And that low that's moving up the Gulf is going to be quite strong. It's going to bring some severe weather there to the Gulf states, especially the Florida Panhandle. So that's GFS 72-hour pressure and precipitation. Here is GFS 72-hour jet stream forecast. So this is what I'm talking about. It looks like the jet stream is going to kind of plow into that tropical system there as it moves into colder and colder water. So its likelihood to remain that strong at 957 millibars will be dropping by about Thursday. Expecting that to weaken at the same time that the Gulf Coast gets hit by some heavy rains. Last but not least, the GFS 72-hour temperature anomaly forecast. We are seeing some extremely low temperature anomalies there showing up around the northern Great Lakes, like the Upper Peninsula and northern Michigan there. Expecting some temperatures like 12 degrees Celsius below normal. 72-hour GFS temperature anomaly forecast in degrees Celsius. Next, lightning for the past about 10 hours. And the heaviest lightning has been in places like Arkansas. Here's our most recent lightning map. Check it out, lightningmaps.org. Here, south of Memphis, there is some thunderstorm activity there. Next time you hear thunder, check out lightningmaps.org. Yeah, you can forecast thunder strikes. So pretend to be a movie villain, or perhaps you can convince the natives that you're Zeus or something. I don't know. lightningmaps.org. Highly recommended. And we highly recommend that you press the subscribe button if you're new to the channel. Thanks to our new subscribers, by the way. We won't be celebrating 4,000 subscribers. We've been making these videos for over 6 years now. It's only the most detailed and comprehensive space weather you'll find in the known universe. Thanks to our longtime viewers. Thanks to the Smash team especially. These videos are brought to you in part by the Smash team, also by Smash staff and I at massive personal risk and expense. Thanks for tuning in. Press like, subscribe, share, etc., especially share. And if you are an influencer, or if you're a content creator, drop us a line if you'd like us to appear on your channel. And support the channel via our links. One of our paid affiliate/sponsors is our Hemp Lucid shop, so check that out. Link below the video, as well as on our homepage at smashomash.com. So help keep this channel in existence by visiting our affiliate/sponsors. Clicks matter, so hook us up with some clicks, and perhaps hook yourself up with some CBD products, maybe some mushroom gummies, some immune stacks, stress stacks, etc. Thanks to everybody who's been shopping. Again, thanks to the Smash team. If you want additional content, head to smashomash.com/smash team. Join at the gold level if you want to know my crap hypothesis. Yeah, my hypothesis is crap. about the solar cycles. Yeah, I've developed a plausible explanation for what drives the solar sunspot cycles. You can read all about it. You can read a bit about it by becoming a gold member at the Smash Team, smashomash.com/Smash Team. There's also a silver level and a bronze level, and we send out email alerts to everybody for videos just like this one. So if you're not seeing notifications on your favorite video hosting platform, YouTube, then you can sign up for email alerts, and then you'll get notifications because we send them out. Period. Today's featured product on the Amazon shop at amazon.com/shop/smashomash is Andrew Unziker's book on the liquid sun, A Coming Revolution in Astrophysics. Yeah, it's pretty serious. By the way, the ebook is, I think, only $10. That's the $24 for the physical book. So check that out. Some various other books there available as well. Today's featured product is one that I'm currently wearing, and it says Universum Liberate. And if you don't know what that means, you're probably not a member of the Illuminati. So, yeah, Universum Liberate. It is the motto of the Galactic Federation Special Forces. If you want to support the Galactic Federation Special Forces, pick up some merch. The symbolism represents the Milky Way galaxy, signal strength and integrity and security, and instantaneous galactic scale reach. Universum Liberate. If I could wave my magic wand, I'd set everybody free. Looking out for freedom and liberty on a galactic scale. It's the Galactic Federation Special Forces. 36 other designs available at the Redbubble shop, which is also linked below this video and on the homepage at smashomash.com. So there it is, and welcome to the Neo Renaissance. Congratulations on realizing the channel exists. We're frankly surprised. Why? Because of the pathetic, evil, putrid, criminal, ridiculous state of affairs when it comes to censorship. If you think anybody has repaired free speech on the internet, think again. Censorship continues. Shadow bans are not free speech. Smashomash.com is an actual endorser of free speech. We encourage all legal speech. And fun fact, we read everybody's comments. We don't delete anybody's comments. We don't mute or ban anybody from commenting. There are many channels that think that they're our competition that have to do that in order to maintain their sycophantic nonsense. And we don't do that. We are free speech purists, not free speech phonies. Know the difference. We're going to close out the video with the latest U.S. Doppler radar. Again, heavy precipitation there in the southern half of Alaska. We're focusing on the lower 48 for the remainder of this video. Engage. There is clouds and fog over the lower 48. Here is water vapor over the lower 48. Here's your recap. Vertical motion in the air column depicted by ground-based Doppler radar systems. Space-based shortwave radiation at 3.9 micrometers. It's part of the infrared spectrum. And there is 6.19 micrometers, a different part of the infrared spectrum depicting water vapor as in all of it. Anyway, once again, thanks for tuning in. Congratulations on realizing the channel exists. Don't forget to press like and subscribe. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash signing off. And may that solar wind be at your back.